Hi, my name is Xijie, and I will be presenting the overview of machine learning in agriculture. So in my presentation, I will mainly focus in explaining the definition and the terminologies that involve in machine learning. Yeah. So what is machine learning? Basically, machine learning is a method to use training data to answer the question or perform a task. So in detail, when we have training data, it serves as an input, and then it will undergo and we will apply the learning suitable learning models for the machine, and then this data will be classified or construct a prediction rules, and we will have the predicted output that we want to see. Basically, when we have the input and it will apply learning models and then undergo the rules analyze, and then we will see the output that we want to see. Yeah, so under machine learning, there are two categories. So in supervised learning is one of the category where the data is labeled, as in there are examples of input and corresponding output. So it constructs a general rule that maps input to outputs. For example, one input data is classified with a general rule to predict specific output. So in another category is unsupervised learning. So in unsupervised learning, the data is unlabeled and the input data is with the goal of discovering the hidden patterns. Yeah. So before implementing the learning model, the data will be analyzed through dimensionality reduction. So what is dimensionality reduction? It's an algorithm to provide a more compact, lower dimensional representation of a dataset to preserve information from the original data. So there are common dimensionality reduction algorithms, which are principal component analysis, partial least squares regression, and also linear discriminant analysis. Yeah. So right now we will go into detail to understand the types of learning models that implemented in machine learning. So in supervised learning models, there are 7 types of learning models in this category, in supervised learning categories. So the first one is regression. So regression is used to predict the output variable based on the input variable. So there are a few examples of regression, for example, linear regression, logistic regression, and stepwise regression. And there are also complex regression have been developed, such as multiple linear regression with more input variables involved to predict output. Yeah. So another type of supervised learning models is Bayesian model. So this Bayesian model is one of the probabilistic graphical model and normally used to predict classification problems by using probabilistic. Yeah, and then another model is instance-based model, which is a type of memory-based models. And this model construct the hypothesis from the data available and classify into the new output. Next, decision tree. Decision tree organize the data set into homogeneous subset to generate tree graph. So in the tree graph, each node represents different pairwise comparison, and each node will represent the predicted output from the root to the leaf. And next, artificial neural networks. So this model is inspired by human neuron function. So in this model, it has multiple processing layers, for example, input layer, hidden layer, and output layer to actually give the decision or prediction. And that next is support vector machine. This model classifies the data by constructing a linear separating hyperplane. Next is ensemble learning, which this model, it aims to improve the predictive performance by constructing a linear combination of simple base learners. So the simple base learners that common use in ensemble learning is decision trees, which to construct a diverse hypothesis among all single models. For example, there are a few of decision trees have been constructed, and then based on all the decision trees, there are a few different hypotheses for us to predict the output. Yeah, the last one is unsupervised learning models, which is clustering. And this clustering basically is just to find natural groupings of data where it groups the data based on their nature. So the common clustering techniques are k-means, hierarchical clustering, and also expectation maximization techniques. Yeah, that's all for the overview of machine learning. Thank you.
Now, I would like to present about crop management. There are 5 components involved in crop management. The first one is yield prediction. Yield prediction is vital in increased productivity by contributing in estimating yield, correlating crop supply with requirement, managing crop and yield mapping. There are few models and algorithms that can be used in yield prediction. The first one is support vector machine. By using this model, coffee fruits still on coffee branch can be colored automatically. This can be done by observing digital image with color. Besides, green citrus fruit which have not matured can be recognized in outdoor naturally. This can be done by observing digital image. This model also can help in predict development stage of rice and rice yield. This data for weather of space, agricultural, and the physics and chemistry of soil is observed with rice yield or records of yield development. The second one is a Bayesian model. These models can detect cherry branches with cherry fruit and leaves with a background. This can be done by observing digital image with color. Next one is artificial neural networks. In general, predictions of agricultural use can be analyzed accurately by using this model. Biomass of glass sand can also be estimated by using this model. This can be done by observing indices of vegetation and respective bands and near infra. This model can use to predict weight within different fields by monitoring data of soil and characteristics of growth. This can be done by using satellite normalized difference vegetation index (NDVI). The last one is expectation maximization. This is an algorithm which can help in detection of tomatoes using unmanned aerial vehicle UAV. UAV will show red, green, and blue RGB images of tomato. Now we have done for yield prediction. We will proceed for disease detection. Disease detection is one of the biggest concerns in agriculture. There are few models that can be used in disease detection. The first one is artificial neural network. By using this model, it can help in detect and differentiate between healthy and plants infected by smart fungus. The spectral image of leaf can be observed by NIR and handheld visible spectrometer. Other than that, conditions of wheat canopy in winter which are healthy, nitrogen stress, and infected by yield rise can be detected. This can be done by observing imaging data of hyperspectral surfactants. The next one is support vector machine. These models can help in detection of strawberry. Type of parasites can be classified and tricks which are tiny insects can be detected in strawberries automatically. This can be done by observing color indexes and region index of strawberries. Other than that, Fusarium fruticoroi, which is a plant pathogen and Bacchanal disease, can be detected in rice seedling by using this model. This can be done by observing color traits and morphology of healthy and infected rice seedling. Other than that, conditions of wheat canopy in winter which are healthy, water stress, and infected can be detected. This can be done by observing fluorescence features and spectral reflectance. Lastly, deep neural network, which is an algorithm, can be used. Plant disease can be detected and diagnosed in various crops. This can be done by observing leaf figures of disease and healthy plant. Now we have done for disease detection. We will proceed for weak detection. There are few models used in weak detection. The first one is artificial neural network. By using artificial neural network, Ceridium maranum can be detected and mapped by observing texture layer and red, green, and NIR spectral band. The which species and genus can also be identified and differentiated by observing hyperspectral imaging spectral features. The second model that can be used is support vector machine. The methods used to classify grass and wheat are reported based on their performance by observing grass and various types of wheat images from camera. Now we have done for wheat detection. We'll proceed for crop quality. Increased accuracy in detecting and categorizing characteristics of crop quality can result in raise of price of crop product and reducing in waste production. There are two models that can be used in crop quality. The first one is support vector machine. By using this model, common types of non-botanical and botanical foreign materials that are attached importantly can be detected and categorized. Images of cotton together with types of foreign materials, which are non-botanical and botanical, are outlined by images from short-wave infrared hyperspectral transmittance. Other than that, cola fragrant pairs can be identified and discriminated into categories of deciduous calyx or persistent calyx. This can be done by observing hyperspectral reflectance imaging. The other model that can be used is ensemble learning. By using this model, the geographical source of rice can be predicted and categorized. By using inductively coupled plasma mass spectrometry, amount of chemical elements that can be found in rice combination are 20 types. We have done for crop quality, now we proceed for species recognition. Species recognition can be held in reduced time of classification and recognition. The model that can be used is deep learning. By using this model, soybean, red, and white bean, which belongs to legume category, can be recognized and categorized. This can be done by observing their images of leaf weight. Now we have done for species recognition. In conclusion, crop management involves yield prediction, disease detection, crop quality, and species recognition. That's all from crop management. Thank you.
Now, I will continue to talk about the application of machine learning in livestock management. Livestock management consists of animal welfare and livestock production. The main purpose of applying machine learning in animal welfare is to detect diseases in their early stage, while for livestock, machine learning is applied to predict the economic balances for the producers according to the production line monitoring. First, ensemble learning is being used to classify cattle behavior. Ensemble methods are used with multiple learning algorithms to obtain a better predictive performance. The estrus and the recognition of dietary changes on cattle are recorded by color sensors with magnetometers and 3-axis accelerometer. The accuracy is pretty high, reaching to 96%. Next, in the study of ruminants' ingestive behavior, the learning model being used is decision trees. The chewing signals of supplementary feeding and the data of behavior are collected using fiber bread grading sensing. The accuracy of this model reached 94%. To track and evaluate the behavioral changes in pigs, Bayesian-Gaussian mixture model is being used in this study. The 3D motion data is recorded using 2DAF camera. The mean multi-object tracking precision reached up to 0.89 accuracy behavior annotation. Now, I'll proceed to the livestock production part. In this study, the rumen fermentation pattern is being predicted based on the meal fatty acids, which can be used to design diets for meal production. Artificial neural network models is used, and from the observation of fatty acid in the milk, we can predict the volatile fatty acid molar proportions in cattle's rumen. Next, SVM model is being used in two studies, where one is to prevent the risk in the commercial eggs production, and another one is to predict the bovine weight trajectory over time. 6 features of the hens is being collected continuously for 7 years, and the early warning is accurate up to 98%. While for bovine, geometrical relationships of the trajectories of rigs is being learned along the time by the models. Based on the geometric measurements of cattle, the carcass weight of beef cattle is being estimated using SVR approach before slaughter. The average mean absolute percentage error is very low, to 4.27%, which is highly accurate. Lastly, instead of using radio frequency identification RFID tags, which making the pigs discomfort, deep convolutional neural networks is being applied in pig face recognition. 15,553 color images with pigs' faces is being learned by the model, and the accuracy is high up to 96.7%.
Now, I'm going to talk about water management. Water management is important in maintaining soil, water, and climate balance in agriculture. There are two components involved in water management. The first one is evapotranspiration. Evapotranspiration is process of combining evaporation and transpiration. The accuracy of evapotranspiration estimation is vital in managing resource and designing irrigation system. There are two algorithms that involve in this situation. The first one is regression. By using regression, mean evapotranspiration in arid and semi-arid area can be estimated manually. Data of relative humidity, temperature which include maximum, minimum, mean, radiation of solar, and speed of wind can be collected. The second one is extreme learning machine. By using extreme learning machine, daily and weekly evapotranspiration can be estimated. This can be done by observing temperature data such as air temperature. The second point is daily dew point temperature. Daily dew point temperature is temperature that gaseous state of water, which is water vapor, saturated in the air. This is important in identifying predicted weather phenomena. There are only one algorithm involved in this situation, which is extreme learning machine. Extreme learning machine can use to predict daily dew point temperature. This can be done by observing relative humidity, vapor pressure, average temperature of air, horizontal global radiation of solar, and atmospheric pressure, which are categorized into data of weather.
We'll continue to talk about the machine learning application on prediction and identification of agricultural soil properties, like predicting the soil drying, the soil condition, the soil temperature, and soil moisture. By understanding the soil properties, we are able to know more about the dynamics of ecosystems and the impact in agriculture. For example, through interpretation of soil temperature, we can accurately analyze the climate change effects of a region, and it is also an important meteorological parameter regulating the interaction between ground and atmosphere, while soil moisture is a key factor for crop yield variability. First, instant-based models or k-nearest neighbor and artificial neural network or backpropagation are being compared in evaluating the soil drying for agricultural planning. The models learn the precipitation and potential evapotranspiration data and able to assess the soil drying in particular region accurately up to 91 to 94%. Next, in the study of soil conditions, models least graphs with support vector machines and regression of qubits are being compared and used to predict soil organic carbon, moisture content, and total nitrogen. A total of 140 soil samples is being observed from topsoil layer of an arable field using visible near-infrared spectrophotometer. To predict the daily soil temperature in two different climate conditions, self-adaptive evolutionary extreme learning algorithm is being used to enhance performance of machine learning. Daily data is being collected from year 1996 to 2005 in Bandar Abbas and year 1998 to 2004 in Cameroon. Lastly, prediction of soil moisture is done based on artificial neural network model, multi-layer perceptron, and radial basis function, using the data of random behavior of forces on the chisel opening of a no-till seeder.
Hi, I'm EJ here. In this presentation, I will be discussing on the application of learning models in machine learning in agriculture. So there are a few learning models have been implemented in agriculture and mainly implemented in crop management, livestock management, water management, and also soil management. So crop management have the most implemented machine learning models. Specifically, there are artificial neural network as most implemented learning models in crop management, and then there are also followed with support vector machine, Bayesian models, ensemble learning, and clustering. And then in livestock management, we also get to know that there are a few machine learning models have been applied here, which is support vector machine as the main machine learning models, and then followed with artificial neural network, decision tree, Bayesian model, and also ensemble learning. So in water management, there are also two machine learning models have been applied, which are artificial neural network and regression. And last but not least, in soil management, there are also machine learning models have been applied, which are artificial neural network, regression, instant-based model, and also support vector machine. Yeah. So in crop management itself, we get to know that there are a few subcategories have been implemented these machine learning models. So first is yield prediction, disease detection, weed detection, crop quality, and also species recognition. So in yield prediction, there are four types of learning models have been applied, and the main learning model is artificial neural network. And next we have disease detection, which applied artificial neural network and support vector machine as the learning model. And then there are also weed detection that applying the same as disease detection and yield prediction with the add-on of clustering. And then the next for crop quality, there are also support vector machine and ensemble learning have been applied as a learning model in crop quality. And then last but not least, artificial neural network model have been applied in species recognition. Yeah, so from crop management, we get to know that artificial neural network is the main and most applied learning models in crop management, and then followed by support vector machine. Yeah, so right now we're going to see the next management, which is livestock management. In this livestock management, there are two subcategories that involve in the application of machine learning models, which is animal welfare and livestock production. Yeah, so in animal welfare, there are Bayesian model, ensemble learning, and also decision tree have been applied. And then there are also in livestock production, there are support vector machine and artificial neural network have been applied in livestock production. So in this livestock management, the main and the most implemented learning models is support vector machine compared to the others. Yeah, and for water management, there are artificial neural network and regression, where artificial neural network is the main learning models that apply in water management. And last but not least, there are soil management that applying support vector machine, artificial neural network, regression, and instant-based model. So to the entire in agriculture, the main applied machine learning models are artificial neural network. Especially in crop management, water management, and soil management, whilst only livestock management, they implement support vector machine as the learning models. Yeah. So in order for us to actually detect the feature of the crops and also observe the feature, there are a few feature techniques that is being used to detect the feature of the crops. So in crop management itself, so digital images and colors indexes have been applied in yield prediction, disease detection, weed detection, and also species recognition. And also NIR have been applied in yield prediction, disease detection, and weed detection. NDVI specifically in yield prediction, and then data records in yield prediction, disease detection, and crop quality. Spectra have been used in disease detection, weed detection, and hyperspectra have been used in disease detection and weed detection and species recognition. And last but not least, fluorescence is used in disease detection. So from here, we can know that the main features technique used is digital images and color index. And specifically for disease detection, there are several techniques that we can use, which is digital images and color index, NIR, data record, spectral, hyperspectral, fluorescence, almost all of them. But specifically for NIR, NDVI, spectral, and hyperspectral is only used in crop management. Yeah, so now we will get to know like how livestock management detect and measure their features. So in animal welfare and livestock production, the two main features technique are digital image and color index and data record. While for water management and soil management, they only use data records as their feature techniques. Yeah, so that's all for the discussion part. That's all from me. Thank you.
In conclusion, artificial intelligence has been popularized for decades across many sectors including agriculture. It is undeniable that the advancement of technology, especially in machine learning, has solved numerous big and small obstacles in increasing agricultural production. As we all alert that artificial intelligence can perform tasks beyond human limits, but it is still not the ultimate solution for everything. We observe that the accuracy of most of the machine learning algorithms fall between 60% to 90%, and a few can go up to 98%. This means that there are still spaces for machine learning to improve. In our opinion, the combination of human intelligence and artificial intelligence will achieve perfection. In this context, we are also taking labor replacement issues into consideration. Experts always remind people to not to rely on artificial intelligence in any circumstances. Robotics and artificial intelligence can perfectly replace most of the repeating and labor-intensive tasks. Thus, farmers should also ride onto transformation from labor-based farming into knowledge-based farming. All information that is produced by machine learning algorithms should be processed by knowledgeable farmers for further analysis and decision making. This paper indeed provides very complete information regarding the application of machine learning in several agricultural sectors. The sectors mentioned in this review paper including crop management, livestock management, water management, and soil management. We face little problems in the process of extracting information from this paper. When we are extracting the information from section 3, we found that the tables in section 3 are a little bit confusing. We will be pleased if a description can be added to further describe the different models used in the particular management. Besides, since many models of machine learning has been introduced and clearly listed into each of the sectors, we found that the author did not explain the reason behind the selection of models for particular sectors. It would be better to have a reason to explain the usage of machine learning models so that the understanding of machine learning will not only at the surface level. One limitation of this paper is that the author only focuses on the currently available application of machine learning in those 4 categories. One very major sector that needs to pay attention is climate change. The contribution of agricultural activity towards climate change and the effect of climate change towards the production level and product quality. From the World Economy Report of Harnessing Artificial Intelligence for the Earth, artificial intelligence can sense the environment, think, learn, and subsequently act in response to what they sense. This is especially important in the effort of balancing output of agriculture and the sacrification of nature due to agricultural activities. The interest of research should not always focus on the output. The interest of research should also be diverted into the effect of agricultural activity towards nature. With the aids of machine learning, we are optimistic to see the future of agriculture. Thank you.